So basically, ladies and gentlemen, what I want to go over is in last class period, we practiced some of these. But as far as the instruction, all we have gone over so far in this class, it was just graphing linear equations. Now, I did go over on Friday, the 2 Fridays, or the last Friday, 2 Fridays, to go over how to use test points. And so we're going to add that in again with this one, and then include our shading. But what I want to do is just go to review on graphing, because as you guys can see, that's what your test is on, is graphing. And we're going to be doing a lot of different graphing. So when you have an inequality or an equation that's in standard form, the first thing we want to do is, unless you want to use intercept form, which you could on this one, but I think the preferred method for a lot of you would be to rewrite this into slope-intercept form. So to do that, remember slope-intercept form as an equation would be y equals mx plus b. So that means I need to isolate the y. So in this equation, I need to solve for y. So I subtract 2x on both sides. I get negative 5y is greater than negative 2x plus 10. Does everybody understand why I rewrote that as negative 2x plus 10 rather than 10 minus 2x? OK. Now I need to solve for my y again. So I divide by negative 5. And I have y is greater than 2/5 x minus 2. Does everybody understand why I had to flip the sign? Because I divided by a negative number. Also, notice that I divided the negative 5 into both of my terms, leaving me with a positive 2/5 x and a negative 2. Yes? I said to flip the sign, but I did not do it. Thank you. I said to flip the sign. I just didn't do it. Huh? So now, guys, we had this conversation before Thanksgiving, right? OK.
Can we please do the word? Please.
So now, the next thing that we're going to go over is now identifying the y and the y-intercept and the slope. So remember, ladies and gentlemen, when we have an equation that's in slope-intercept form, here is the constant is our y-intercept, 0, comma b. So the first thing we want to do is determine, well, my y-intercept then here is 0, negative 2. So I'm going to go and plot that point. So here's my origin at 0, 0. On the y-axis, I'm going to go down to 0, negative 2. And I plot my point as my y-axis. Basically the easiest thing. OK? Now, any questions with that? Negative 2, y-axis, go down to negative 2. Then the next thing is now I need to use my slope. Now remember, slope, we identified the slope as a fraction. And the reason why we wanted to write it as a fraction, not only because of rise over run, but we like to always say, the slope is the change in the y-coordinates over the change in the x-coordinates. So if you do have a slope that is a whole number, write it over 1 so that you can have a fraction. So you can see here, my change in my y-coordinates is positive 2. So from my y-intercept, I need to go up 2 units. And then the change in my x-coordinates is 5. So I'm going to go over 5 units. So up 2 over 5. Let me write it better. So I find the y-intercept. That's the first point I plot. Then I use the slope to find my next point. And then I can connect. But the one thing we did not discuss yet this class was determining the shading. Just like when we did graphing its one variable inequalities, we had open and closed dots. Now, ladies and gentlemen, whenever we have an inequality that is less than or greater than, that's going to provide a dashed line. And when it's less than or equal to or greater than or equal to, it's going to be a solid line. And the reason being, just like we saw with one variable, when it's an open circle, it's not a part of the solution. When you have a dashed line, that means any point that lies on that dashed line is not going to make your inequality true. So it's not a part of the solution. Then the last thing we need to do is use a test point. And the best test point to choose is going to be, anyone? 0, 0. As long as your graph does not go through 0, 0, right? But you can see that my graph does not go through 0, 0. So then all I'm simply going to do is plug in 0 in for y. and 0 in for x. And what I have is 0 is less than -2. And is that true or is that false? That is false. So since my test point is false, that means all the points above my line are false, and all the points below are true. So to represent, since all the points are true, we shade. OK? That's it.